Okay, chapter 1.3. We're talking about domain and range still, and we've been talking about domain and range for a while now. Domain is x, range is y. Domain is all the x values that x can take on where they correspond to a corresponding y value. And you are always going to read your domain from left to right. Your range is going to be all the y values where it can take on where they have a corresponding x value, and this is going to be read from bottom to top. Super important for your brain to understand that. Now we've kind of already talked about all these. We have the infinity, negative infinity. The open dot excludes the value. The closed dot includes the value. The brackets include. The parentheses exclude. And then we always use parentheses with infinity symbols. So now, determine the domain and the range in f at 0 of the function. Okay, domain is going to be read from left to right. So since domain is going to be read from left to right, the very first thing we're going to do is we're going to say, okay, what parent function is this? The parent function is either y equals mx plus b, x squared, x cubed, the square root, something like that. This is a parabola, which means it has arrows that goes on forever and ever and ever, and the parent function is going to be x squared. Okay, so if this goes on forever and ever and ever and ever and ever, it goes all the way off the board, all the way off the board, all the way down into the floor, all the way down into the dirt, and it goes on forever and ever and ever. The arms get wider and wider and wider and wider and wider the further and further you go. If you can put arrows on it, then it's automatically x is an element of the reals, and there is no domain restrictions, meaning that's from negative infinity to positive infinity. And that makes sense to you. However, if we're talking range, range is read from bottom to top. So where do I first run into this graph? I run into this graph at the smallest possible y value in the world, which is going to be negative infinity. And where do I stop running into this graph at? I stop running into the graph at positive 1, and it can be that value, so that is why you're going to have from negative infinity to 1 with a bracket. Now, how do I write this in the set notation? Y is an element of the reals, and y can be any value as long as it's less than or equal to 1. Okay? So that brings us to the last thing, and the last thing is going to be evaluating this thing at f at 0. F at 0 says I am simply going to say, well, here's 0. What is the corresponding y value? The corresponding y value is going to be the coordinate 0, 1. So whenever x is 0, your y coordinate is 1. Let's do that all again. Same exact thing. I can put arrows on this thing, and it can go forever and ever in both directions. So if it's going forever and ever in both directions, that means, if I'm reading it from left to right, x is an element of the reals, and I have no domain restrictions because the graph is completely filled the entire way. It keeps getting wider and wider and wider and wider and wider, meaning negative infinity to positive infinity. The range, this arrow right here, the bottom left corner, this arrow right here, that means that this thing is going down, 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 down forever and ever and ever. The lowest y value that this can be in the world is negative infinity, and it crosses it. Then this value right here, this arrow, is going forever and ever and ever and ever and ever up into the world. So the highest value can be, it's going to be positive infinity, which means y is an element of the reals, and there are no range restrictions. Our last thing is we want to find out what f at 0 is. Okay? Well, that means I want to know where it crosses the y-axis. It crosses the y-axis at this handy-dandy little point right here, and that point is going to be the point 0, 2, meaning f at 0 is the y value 2. Again, determine the domain and the range of f at 0 graphically. Domain, we read from left to right. So as I'm coming to this graph, I first cross it at the value 1, 2, 3, 4, 5, 6, 7, negative 7, and then 1, 2, 3, 4, 5, 6, 7, positive 7. And it can be those values, so I'm going to put brackets. That's interval notation. So x is an element of the reals. The x is trapped between those two numbers. I'm automatically going to go ahead and put less than or equal there. My range is read from bottom to top. So if I'm reading my range from bottom to top, I first run into this graph at 1, 2, 3, 4, 5, 6, 7, at -7. And it can be that value, and then when do I stop running into that? I stop running into it right here at 0, and again, it can be that. So that means y is an elm of the reals, -7 and 0, there's y's trapped in between them. And I simply go ahead and put -7 is less than or equal to y, which is less than or equal to 0. And our last thing that we want to know is going to be f at 0. So where does this thing cross the y-axis? So if it's crossing the y-axis, it crosses right here at this lovely point right there. And what is that point going to be? That is the point 0, -7. Okay? 0, -7. Next, determine the domain of the range of f of 0 on this one. Okay, super easy. These are extended. This is a piecewise function. This is what we call a piecewise function. So as you're going from left to right, when do I first run into this graph? Well, it looks like I run into it right here, which is probably at about 1, 2, 3, 4, 5, 6, 7, 8.25. So I'm going to run into it at 8.25. Sorry. And then it's going to tag along here. And it's going to come right here. And I have that 1. It's going to be closed here, but open there. But I keep on chugging until right here, which is 1, 2, 3, 4, 5, 6. So it goes to 6. But can it be 6? Nope. It's open. So x is an elm of the reals. And -8.25 is less than or equal to x, which is strictly less than y? 6. Strictly less than. Okay? Your range. Your range is right from bottom to top. This arrow means that it goes on forever and ever and ever. So if this arrow goes on, but it really doesn't. You think it does, but it really does not. This is not something that goes on forever and ever and ever. That is not an arrow. It kind of stops right here, and it has a closed dot there. But then it hops up here and has an open dot, and then it's going to go all the way over there. So with that being said, my range is going to start at the value -2, it looks like. And then it's going to go all the way up to the height of this right here, 1, 2, 3, 4, 5, 6, 7. But it cannot be the value 7 because it's an open dot there. So that's parentheses. So that's going to be y is an elm of the reals. -2 is less than or equal to y, which is strictly less than 7. Now, if I want to know what f at 0 is, f at 0 is going to be this value right there, which is going to be 0, -1. And then you're done. The last thing we have is the vertical line test. The vertical line test is the test to see if the function is a function from y to x, meaning if I draw a vertical line anywhere on this graph, crosses at 1 and only 1 time, so yes, this is a function. However, if I do, let's say this, that crosses it in 2 places, so no, this is not a function. And if I have a circle, it crosses it in 2 places, so no, it is not a function. So that is all you have. Tonight's homework is section 1.3, bookwork, page 38, 1 through 16, all.